Welcome back. Today we will be talking about real numbers. As you can see on the screen, I have already written that real numbers are quantities in everyday life because it is a real number. So basically we are saying that they are not any imaginary number, right? Imaginary number can be a radical of a negative 2, something like that. So when we are talking about the real numbers, we are just talking about age, maybe miles per hour, when we are talking about a quantity in a number sense. So the real numbers, they include the price, etc. So that is what the real numbers are. Now, building up on this concept, we can also say that the real numbers can be subdivided. Real numbers is a big umbrella, and under real numbers there are different subsets, different categories that are there under real numbers. And on the right hand side you can see 3 dots. Those 3 dots, it is a shortcut to write because, and these 3 dots, they just consecutive to each other, they are called ellipsis points, and it means that pattern continues. So these are little teeny tiny way to understand the notations little bit better. So as I was saying, that the real number is a big picture, and under it there are many things. There are positive numbers, there are negative numbers, and 0 is also included in the real number, right? Then we are talking about something called, you might have heard about the rational numbers, irrational numbers, integers. So they are the subsets of the real number. So the real number is a big umbrella, as I said, and it is called a set. So set is a collective collection, and subsets, they are different pieces of the set. So under real numbers we have irrational number and rational number. And when we are talking about rational number, we are talking about different types of numbers. For example, integers, we are talking about non-integer fractions, which is positive and negative. And we can write these as the set of these small umbrella under the big umbrella of real numbers. For example, if I have to say set of natural numbers, set of whole numbers, set of integers. So we can write this in a more mathematical way, and we can write the notation using n for natural number, and rational number is nothing but p over q. That means anything is a fraction, anything in the fraction form, provided that the denominator should not be equal to 0. Irrational numbers, they are non-repetitive decimals, and they are non-terminating decimals. So the best example is pi. Pi keeps on continuing, 3.1415 and so on. There no decimal continues, so there is no specific pattern in pi. So those numbers are irrational numbers, right? So coming back to the set of natural numbers, whole numbers, and integers. What are natural numbers, if I may ask you? So natural numbers, you have been learning about natural numbers ever since you started to speak, even before the kindergarten. So natural numbers are also called the counting numbers, because we start to write the numbers from 1, 2, 3 and moving forward. So we can denote the set by n, and because they are counting numbers, we are starting from 1, 2, 3, and then the pattern can continue, and we are using 3 dots, that is called ellipsis points. Now what is the difference between a natural number and a whole number? So whole number contains the natural number or the counting numbers. So as the name implies, whole number, we can denote by W. It starts from 0. So 0 is also included. So if I write 0 and then continue with the natural number, that becomes the whole entire group of whole numbers. Now I can write another set, which is a set of integers. Let's denote by z. So integers, they are, if you remember, you might have seen a number line. On a number line, we have positive number on the right hand side and negative number on the left hand side, right? And those two, positive and negative, they are separated by a 0. So that is pretty much the integers are. So we are continuing on the left. So we are starting with 3 dots ellipsis point, -4, -3, -2, -1, 0. And on the positive side, we can continue 1, 2, 3, and so on. There is no finite number, right? We are talking about integers going forever, because it can be any number on the positive side or the negative side. So this is pretty much the whole entire gist of the real numbers. In your textbook, you might see a different notation for the real number. That is how to write with the r. So we write 2 straight lines and then make r. This is very, very important notation to denote that we are talking about real numbers. For example, in Algebra 1, you might have written about the range or the domain, all real numbers. So this is what we are looking for. Now, 2 key points. Imaginary numbers, they are not real numbers. This is what I stated earlier when we started the video. So when we try to find out the radical of any negative number, that is imaginary number. And you know the imaginary number is denoted by I. We will talk about imaginary number more in detail later on. And the another thing that we need to keep in mind is infinities. Infinity is also not a real number, right? So infinity is not finite, right? So that is why. Now, basic operations. So you know what are the basic operations of mathematics? We are talking about adding. We are talking about subtraction. Then repeated addition is called multiplication. And lastly, we are talking about dividing. So these are the basic operations that you have been learning ever since in elementary school, right? So the same operations we can perform with the real numbers. Then also you have learned about PEMDAS. Please excuse my dear Aunt Sally. So the same operation, the basic operations, the PEMDAS, we will follow the same common things with the real numbers. When we are talking about the fractions, we can talk about adding and subtracting the fractions in 2 different ways. We can talk about adding and subtracting when the denominators are same and when the denominators are different. So let's discuss about basic operations of fractions. So let's talk about with the common denominator. So common denominator or like denominators, when we have to add 2 fractions or subtract 2 fractions and the denominators are same, then our life becomes a little bit easier, because in this example 3 and 3, both the denominators are same. We can just add the numerators together and we can keep the denominator as it is. Do not add the denominators. We don't add the denominators, we just add the numerators if the denominators are same. So the common error what I have seen is 2 over 6. 2 over 6 is a wrong answer. Now, adding and subtracting with unlike denominators, right? So unlike or different denominators. For example, if we have 2 fractions where the denominators are totally 2 different things. Let's take one example. So 2 over 3, and let's add to 1 over 5. So as you can see, 3 and 5, they are unlike, right? But can I do something to make both the denominators same? We can multiply the first fraction by 5 and multiply the second fraction, numerator and denominator, by 3. Whatever operation you perform in the numerator, you have to perform the same thing in the denominator. And with this, you are getting the same common denominator. Now this problem is can be solved the way we solved the previous problem. All right? So 10 plus 3, which is 13. So 13 over 15 will be your final answer. Now, let's talk about another operation, which is multiplication. Multiplying two fractions, they are the easiest thing to do. Because when we are multiplying the fractions together, the only thing that you need to understand is multiply the numerators together and multiply the denominators together. So NUM, I'm using NUM as a shortcut for numerator and DEN as the shortcut for denominator. So let's take one example. So in this one, multiply numerators together, multiply denominators together. That's it. That is your final answer. Now let's revisit how to divide the fractions. So dividing fractions, you might have learned dividing fractions in elementary school with the area model, and that was painful, right? So we have a shortcut to divide the fractions. I have made another video, the shortcut to divide the fractions, and you can find the link for that on the upper side right corner. So basically, when we are dividing the fractions, we are talking about reciprocal of the second fraction. And then continue the problem as if you are solving the problem for multiplying the fractions. So for example, 1/4 divided by 3/5. So the answer will be 5/12. So this is basically the whole entire operation. And fractions, you need to understand the operations with the fractions really, really well. Now, there is another thing in this unit that is called fundamental theorem of arithmetic. Now, this might sound a little bit scary, but they are talking nothing else but only about the prime numbers, the prime factorization, right? So every positive integer that we are talking about, which is greater than 1, we are using those positive integers which are greater than 1 to calculate the prime factorization of any number. For example, if you have to find the prime factorization of 32, so you can start factoring it by 2. So there are 5 2's that are multiplied together to make it 32, and 2 is greater than 1. And remember, 2 is the only even prime number from 0 to 100. Now, one very, very important thing is 0 and 1 are neither prime nor composite. They have their own special identity in their own. And this is how you need to understand this. Now, the another important thing is interval chart. When we are talking about the interval chart, we are talking about the bounded intervals, right? So when we are talking about the bounded intervals, that means what is included, right? Or what is not included when we are talking about real numbers on the number line. So let's expand on this. So let's say we have A and B. They are the endpoints. Of each interval. Then we are talking about something called closed interval. So A and B, they are endpoints of any interval, and if they are in the closed interval, we are using these symbols because it implies that these two endpoints are included. So endpoints are included. So when we use the brackets, that means we are talking about the closed interval and it is included. For example, x is greater than or equal to 3, because equal to sign is there. That means 3 is included, and 3 and anything greater than 3 is your answer, right? So the inclusion part is there with the bracket. Now, the another thing is open interval. So for the open interval, we use parentheses. So there is no equal to sign in this case. So we are talking about the endpoints are not included because there is no equal to sign for these type of problems. Let's take one example. X is greater than 3. So as you can see, there is no equal to sign. That means when we are graphing it, it will be open circle. It will not be a closed circle. It is not the colored circle. The circle will remain open. So any number beyond 3, but not 3. Now, few important things. When we are talking about intervals, let's talk about in terms of infinity. So positive infinity and a negative infinity, they are not real numbers. I have discussed this previously. Infinity and negative infinity, they are boundless, unbounded. There is no finite number. That is why they are not real numbers. And it is very convenient to use these symbols to describe unboundedness of the interval. So because they are not real number and they are talking about unboundedness, whenever you use the symbol infinity, always use the open intervals. Never use the closed interval. As in this example, 2 comma infinity, that means 2 is also open and infinity will always remain open, right? Let's discuss about this chart. In the first example, if you can see, we have the brackets, right? So bracket implies closeness, inclusion, and same as the graph. A and B both are included. In the second example, we have parentheses. So that implies openness. It is not included. No inclusion is there. And that is why in the inequality equation, there is no equal to sign. And that open bracket is also displayed on the graph. The third one, A is included, but B is not included. In the inequality, it is less than or equal to between A and X, but X is only less than B. B is not included. And the same pattern continues with the fourth one. So these are the bounded intervals on the number line. You should understand this extremely well because this will become the foundation for accelerated algebra 2 and including the precalculus and the calculus and moving ahead. If this basic structure is not clear, then it will become a bumpy ride. Now, let's talk about unbounded intervals. Because it is unbounded, we are talking about infinity or negative infinity. And we have discussed earlier, whenever we use infinity or negative infinity, we always use the open intervals, right? Because it is we are talking about a line, and line continues forever. There is no end point for a line. That's why when we write the notation for a line, it has 2 arrowheads on both sides, right? That is the basic principle of line that you might have learned in geometry. So infinity and negative infinity, always use open circles. Now the absolute value. Absolute value of a real number, as we know, absolute value, we are talking about magnitude. Magnitude, we are talking about distance. It will always be positive. Even we are talking about a negative number, if it is in the absolute value bar, it will turn into a positive number. It is very crucial that you need to understand the piecewise function. How to write the absolute value in a piecewise function. So if a is a real number, then the absolute value of a will be a if a is greater than or equal to 0, but it will be written as negative a if a is less than 0. For example, a is -1 or -3, right? But the absolute value of -3 will always be 3. Whatever goes inside the bar will comes out positive. So these are the basic properties of absolute value bar that you should understand. I hope this lesson makes sense, and I will see you in the next video. Thank you for watching. Make sure to like and subscribe. Bye bye.